products first. Hello. Oh, so loud to be here. I'm Marcia. I'm a full-stack developer at Rovio. And I imagine all of you knows Angry Birds. No? Do you? So quiet, man. Come on. You just eat. You need to wake up. So if you don't know Angry Birds, you should. It's one of the most known brands in the world, so I hope you know it. If not, you're living inside a box. Stop coding and go out. I'm a full-stack developer there, and I flew all the way from Finland because I'm living in Finland, and Rovio is a Finnish company, if you don't know, and to tell you a story about how we migrate one of our products from normal instances and all that stuff to serverless. So the first thing I want to tell you a little bit about is the product that we migrate, so you get a little idea of what I'm talking about. So the product is called Toons TV. That is like Netflix for cartoons. So it's not like Netflix. We don't have subscription model, and you don't need to pay. But basically, you start the app. You watch cartoons. You watch ads. You pay my salary. Thank you very much. And we are multi-platform video on demand. So we are in different platforms. We are inside Rovio games. We are inside, we have our own app. We are in TVs and smart TVs, Apple TVs, in many, many different kind of platforms. We are also globally available, but in the States, you have much content than anywhere else because you have most of the advertisers here. And we've been live for 4 years, and since then, we have 8.5 billion views. That's a lot of views. And that means a lot of requests per second if you're a backend developer, and that makes my job pretty interesting. But there is always but. We have a lot of problems. And that was something I think everybody has, but we had some. And first, we had legacy systems. In Rovio, we had our own managed services that they are abstract in AWS, so we don't need to care what AWS does that much. We can live on our managed systems. And when we built this product 4 years ago, we took what was the managed systems at that time by Rovio, and we started developing on it. But those systems change, and they become more focused on games. But we are not a game. We are a video-on-demand system. So the new systems were not really good for us. So whenever we want to do a new feature, that really slows our development. So that's one big problem, when you want to be fast and you want to get new things out. Another problem is our cost. When you're sending video and you're not charging for it, you have to be very, very aware of your cost. We have optimized as much as we could our videos presets, so the transcoding of the video is the minimal that we can send so the customer doesn't complain about quality. But we have our other problems with cost and transferring data. And then in Rovio, the teams are pretty small. So if you have 3 backend developers, you have a big team. So we had 2, 1.5, because I'm also the iOS developer. So my colleague was doing a lot of the backend, and I was helping, but that was a big problem for us. So this is my agenda for today. I will tell you a little bit of all the different things that we did in order to migrate from the traditional instance world to serverless. And the first thing is that training your team is possible. You don't need to go and hire all serverless developers because there are not that many, and we all can be serverless developers if we know what we are doing. Then do proof of concepts. Don't go directly to production. I think serverless is a great tool for building proof of concepts, and I will tell you our stories about that. Don't forget to optimize your architecture for the cloud. The cloud has a lot of advantages, but if you just grab the instances and drop them in API gateways and Lambdas, you might have the same problems that you had before. So think about it and try to solve your problems in a more smart way. Don't forget about testing. I think in all the talks, people have talked about testing, so don't forget about it. Make your pipeline automated, so you can forget about that as much as you can. And there's still a lot of open questions with serverless, so I will rant about that as well. Well, the important thing is that we were 2 developers, 1.5. And last summer, when we started this, we had, usually in the summer, we fix all our technical debt, because that's what people do on summers. People go on holidays, and developers stay in, and they fix all the things that we were planning to fix, as there is no managers to bring new features. So we sit there, and we're like, OK, we have this high-cost thing going on. We need to find a way to reduce it. So we start thinking about, like, we had a Java instances and Java servers. And we start looking at that, and we're like, whatever we do is just patching the problem. We are really not solving the problem. And also at that time, serverless was becoming very, very buzzy in Finland. There was so many meetups, there were some events, and AWS was pushing Lambdas everywhere, so we were calling our technical account, like, you should try API Gateway. It's like, why? What is this for? And then we start like, okay, maybe there's something there. So we start tinkering with the idea of going serverless and using serverless for maybe solving our problems. So in our free time, we're just drawing these architecture diagrams on how we can really solve this problem, and also start tinkering with the different technologies. And we noticed that we knew nothing about AWS because our platform was managed by Rovio's managed services. We were not in contact. So our manager kindly sent us to an AWS architect course, and we got to know everything about it. But it took 3 days, so it's possible. You can be a backend developer and get trained, and we are smart, so don't underestimate us. And the other thing we did is that we realized that we will need to create our own pipeline. So to do our own pipeline, we need to have knowledge on that and also time. So we decided to incorporate a new team member. We tried to look for a backend developer with DevOps capabilities. So we take care of our ops, so for charity, that we don't forget that. So we hired this guy. He was really good backend developer and had a lot of visions on how to make pipelines and how to maintain and monitor systems, so that was great. And also, as Rovio is a serious company, we don't seem very serious, but we are. We got on board a consultant to help us in this process. He has been doing a lot of serverless migrations, not many because they are not, but he's been working with those, and he has experience on what we need to do. So the first thing we need to do is get everybody on the same page. These are all our cartoons. And that means getting our backend developers, existing backend developers, and also the new guys. So we got everybody together, and we started one thing that I think was crucial for the success of this project, that is having weekly workshops. Getting everybody 4 hours a week in a room and start discussing what are your problems, what you need to solve, what is the smart way of solving, because when you cannot use Google for browsing what is the problems, like in serverless, you cannot go, what is the best way to monitor a server? Serverless, there is no very clear answer. So when you have 4 smart guys and you put them in a room for 4 hours, you might find very interesting solutions. So we start doing that, and also during those weekly meetings, we start building our proof of concepts. And this was another big step for us into solving our problems. So we built 5 proof of concept that we thought that they were like the key problems that we wanted to solve. The first thing, we call it identity, that is basically migrating from the managed service of authentication from Rovio to using Cognito user pools. And that, I was building the authentication service from Rovio, and I was there for 1.5 years. We had shed a lot of bugs, and I was like, oh my God, if this is the first proof of concept we want to do, we are going to die. We will spend here forever. But no, in 1 week, we have this running with Lambdas, API gateways, and user pools. We had 3 endpoints. It's a token machine. We can register users, get new tokens, get profiles, and with a little checkbox in the API gateway, we were able to authenticate all our API calls. So it was pretty impressive. The next thing we wanted to do is to remove our managed database from Rovio that we were using the NoSQL database called RIAC, and we wanted to drop that and start using something else. And we picked DynamoDB, so we built a proof of concept of that. Then we wanted to check the Elastic Transcoder and Lambda, so we built another proof of concept of that. And then we did another image resizer, because image resizers are cool. And if you have any questions on this, you can ask me on Twitter or ping me around, but I won't go into details. I should just go into details on the last one. Because this one was the one that was giving us the pain. That was our high cost. And that's a simple summary of what our problem was. So we had, in the previous land, in instance land, we have a service that was getting a request from client. The request was built up with multiple parameters. This is a service that had been built 4 years ago, and we never really touched the way these things interact. So we had many parameters. Some of them that were business critical, like the country and the application, the code the request was coming from, because we have contract signs that we cannot show this content somewhere else because, you know, advertisement and copyright and stuff like that. But other parameters that were not that critical, like the image, the screen size, and which platform is running, not important. We can deal with that. And there were others like that. So when those many parameters comes in the request and go to the server, then our cache hit was super low, because there were so many parameters that we had around 10% cache hit. That's not good. So the service needs to process all the requests, and there were many requests coming, and then return a response. And this, between the service and the phone, is super expensive if you're not using CDN. And if you have 8.5 billion views, and you have lots of devices connecting to your backend, this becomes petadata, massive. And then your manager is like, whoa, this is a big deal. And they start complaining on you. So that was the problem we want to solve. It's very silly, but it's very expensive. So what we did is we decoupled the whole thing. And that's what I mean by rethink your architecture. Don't worry too much about my architecture, because that's my problem, but you might have similar problems that you want to solve. So the idea here is for you to think about in a different way. So we had first this kind of request-response thing, but now we decided to decouple the whole problem into two. As our content didn't change much, we were able to do like a cron job every 10 minutes to fetch from the database the content and put it in a bucket. And the bucket is natively CDN. So that's good. And also, in order to get all these variations in place, we chop all the extra things that were not part from the business, and we just keep two parameters. So we keep the country and the application. And using step functions, we were able to pre-process all the different variations, that there are not that many, build JSON files, and store them in the bucket. So now, all our variations are generated because our content is super static. We don't need a server to create the same thing over and over again. It's very stupid. So we solved that. Good. Now we have static content here. And then it's very easy. When the request comes, a Lambda will return that JSON file from the CDN, and ta-da! And as everything is content, country like pre-processed, every country has their own thing in their CDN, and it works like charm, and it's pretty cheap. So yeah, we solved that problem. Now let's start working, because this is proof of concept. So we validate with our management that everything is fine. So we build our critical path, the most important thing, so we can go to production as soon as we can. And we split the work between the developers. So it's not one server per developer. It's like everybody gets a different piece of this thing. So yeah, so now we have a mess. We have millions of lambdas, millions of resources, millions of databases, and transcoding and things flowing around. So we decided to organize things in like microservices kind of things using serverless framework. So everything that belongs to the content API will be in one serverless framework project, and everything that belongs to transcoding will be in one serverless framework project. And then we had, instead of millions of resources floating around, we have maybe 10 that everybody represent a different microservice. And then it's totally easy to manage, because then you can have Git repos, and you know if you deploy the content, everything of all the resources will be deployed. So we call that the service stack. But then there were some resources that were shared between multiple like stacks or services, like our documentation bucket, our domains, our SSL certificates, and we wanted to have everything as code. We don't like just to have our infrastructure depending on people remembering to tick boxes. So for that, we create a permanent stack using Python and the CloudFormation. So we also get a repo, and then whenever we need a new environment, we change a couple of environmental variables, and poof, new environment is up. Very fast, very nice, and everything is on GitHub. So we can track it, we can see who did what, and so on. So yeah, going to our pipeline, that was also an important thing for us, because we are coming from this kind of, Rovio is a corporation or enterprise. We have everything automated. So for us, not having an automated pipeline and how to write in command line deploy, it just sounds so weird. So if we go to production, we wanted a machine to do it for us. We don't want to trust our developers in doing that. So we started from the beginning to automate our platform. And for that, we took the decision to have 3 different AWS accounts, one for development, one for staging, and one for production. And why we did that? First, because everything is isolated, and less mistakes can be made. Whatever is in production is in production, and then you can have very close attention on the monitoring and everything. You can really focus your attention in where it's important. And then because you have a lot of soft limits. So if you are doing load testing, then your production can get compromised because you are utilizing the same resources that your customers are using. And when you have a lot of demand, you need to be aware of your soft limits. So that's the 3 accounts. And then it was very easy. When we push to develop branch, then Jenkins will take that and deploy. And the same happens when we do to master. And then for production, we have 1 button that we want to press because we are not that brave yet. So yeah, that was pretty simple, and it solves a lot of our problems. Then testing. I love this picture. Yeah, testing. I think we all have been there. I think we started with unit testing from day 1 that we were starting with our production code because that's the way we roll. Let's unit test everything. And then we realized that no. 100% coverage in serverless doesn't make much sense because you end up testing your places that they don't need to be tested because, well, you need to test them in a different way. You don't need to test them with unit tests. And also another thing, we realized that we were running unit tests against managed service in the cloud. And we didn't want that because that slowed a lot of our unit tests. And whenever you didn't have internet, all your unit tests start failing. And you were like, what? So we took the decision that only to test, unit test, our business logic. So we need to create an abstraction that we manage to separate the business logic from the rest, and then we can properly test our business logic in unit tests, and then do integration tests for the rest. Because if not, our unit tests were taking forever and failing, and if you were working from beach, then they were not working. You cannot code. But then that changed the problem to integration tests. And we did a lot of integration tests. When you have serverless, everything is so decoupled, everything is moving in their own life, and you have no clue. So having good end-to-end integration tests is critical for making sure that everything is working. But when developers are coding, they love to deploy to cloud because you want to test locally if whatever you are working now works. Everybody loves that. So we had Jenkins that was deploying to the development environment, and also we had developers that were deploying to the same place that Jenkins was. So whenever you were running integration tests, sometimes it was failing, and we were like, why? Oh, because Lina is working on the authentication system, and I'm trying to I don't know, this other system that depends on authentication system, but she's breaking it. So we decided to have different stacks that you can deploy from your machine to the development environment, but you will create a totally different stack. So we have this kind of local stacks. They will be in the same AWS development account, but then the integration test will always work because the integration tests are talking to each other and they're not talking to the stack that you just created to try if your service works with the database or it works with the thing. So in that way, it was pretty nice because then every developer was able to break their system as much as they want and then make sure when they deploy when they commit to the develop branch, everything should be working, but not before. And you can do as much as you want. And that was really important to have the separated stacks. And the last thing I want to say about tests is our load tests. So whenever you're in serverless world, at least that's what we thought, everything is scales. We don't need load tests, whatever. Nope. The first time we did load tests, we got a call from our AWS technical manager, like, what are you doing with Cognito? Yeah, you're getting timeouts, yes. So we found the soft limits of all our managed systems. And I think that's very important when you have a lot of customers and your system can peak anytime. You need to know what your soft limits are, and you need to be aware of them. And if you're reaching them, maybe it's time to call Amazon or whoever is your provider and tell, can you raise it? But you don't want to raise it beforehand because that can also lead to problems in the future. If somebody is like wanting to attack you, then you're letting them spend all your money. So I think it's good to keep them there, but it's good to know where those limits are. And I think in serverless, it's kind of tricky. People think that systems scale to infinity and beyond, and they don't. And that was one thing for us very important on load testing. Another thing we did is to know how much this system will cost. We used load testing for that because we didn't have a clue how much this would cost. We promised our manager this will cost less, but we didn't know how much less it was. So we used load testing for finding out our pricing. I don't know if that's the right way, but it worked for us. But yeah, so there's a lot of things failing in serverless still, but I think I need to do my ranting about it because everybody did, and I want to be everybody. For us, the biggest pain problems was how much is too much? How much is enough monitoring? How much is enough debugging, testing? How much we need to test? Because this is a new land, so you sometimes go for too much, and then you spend so much time doing things that they really don't bring any value. And at the end of the day, you really need to think, like, your time is expensive, and the more code or things you put out there, you will need to maintain. So you need to find what is the soft, nice limit of enough. Because you can go overboard and create unit tests and integration tests and load tests for everything in the world, but they might not bring any value, and it's code and it's things that you need to maintain later, and maybe you don't maintain. So for me, as there is not much expertise yet around, and I don't have much experience with serverless, this is my first project, and my colleagues the same, we don't know how much too much is too much. So we were playing a lot with that, and I think now we are dealing with monitoring, and sometimes we have some requests that we don't know where they get lost. So, and then we start realizing where we need to add our monitoring and how much enough logging is, how much the logging is important and how much it's sometimes very confusing. So that's one big issue for me. And then there's stupid things that we don't know how to do. And I don't know if there is solutions, but we've been finding all these solutions around the way. And for example, one of the things I'm finding now is how to run one Lambda at a time. I want a singleton. I don't know, maybe it's possible. I still could not find out how. But that's kind of things that you give for granted in the instance world, that you just have one instance of this thing, and this thing is only touching the file system. Now you have 20 million lambdas touching the file system and all poking around your files. I'm like, I don't want that. So it's kind of something, these things that you give for granted in the instance world, they are not for granted anymore. So it's good to be aware that you will find these problems around, and you will need to hack it or find solutions, creative solutions. Another thing is change. There is so much change. Since we started with this project, first we have written the authorizing Lambda for the API gateway, and then next week, Amazon launched the magic tick that you can select the authorizer from the user pool, so we throw that code to the trash. Then we wrote an orchestrator Lambda to handle our pre-processing, and we're very proud of it. And then Rainband step functions came in, we throw that code to trash. So you need to be prepared to rechange things and think about new things that are coming, and be aware what is coming and how the whole environment is changing. And you might need to throw a lot of code to trash, or you might need to reevaluate your solution. And also related to change, as this is a very new and green field, there is a lot of things changing. For example, serverless framework change every 2 weeks. They bring new releases. So when you are like, OK, everything is done. Now our 10 microservices are working, and new release comes. Then you spend 1 day updating and verifying that nothing's breaking with the new version of serverless framework. So that's like the cost that we need to pay for this new cutting-edge technology. And you need to be updating your system. You cannot leave it behind, because the farther you leave it unupdated, then the harder it will be to update to the new version. So that's one of the things that we are dealing with. But it's negative and positive problem at the same time. So yeah, I will wrap up a little bit, because they will kill me, the time. And for me, this project was one of the most fun projects ever, because I could not Google my answers, so I need to think them. And for a developer, that's weird. Usually we go to Stack Overflow, and they're like, OK, how you do this? Oh, yeah, good. But now you need to really think your solutions, and I think that weekly meetings was really good for us, because we can gather 4 good developers in a table and start debating about what is the right amount of unit tests and how you do your monitoring, and let's try this and let's try that. You try that, and then you bring the solutions to the table, and then we all discuss. And I think when you talk and you communicate, a lot of cool things come out. So imagine this conference, 4 people, once a week. It's good. Then another thing we did is use proof of concept, and think if you're starting a new project, don't go directly to production. If it's something that will change the core of your system, as this was for us, try to make sure that this will bring any value at the end of the day. Don't just, oh, it's cool, let's go serverless. No. Think about it and do proof of concept and try different approaches and think about it. Because building proof of concept is super fast. In less than 2 months, we have all the proof of concept, and we done our research, and we were more comfortable with the whole environment. Just if we were starting with production code, it will be super crappy. Also, the use of managed services was great because it gave us the capability of have a very small team and be able to do a very big service, because now we were like not reinventing the wheel, we were using the authentication, the databases, the analytics, and everything that was coming from AWS, and we didn't need to write it ourselves. But yeah, you need to have the ops in the team, and everybody needs to be trained for that, so I think that's important, that everybody in the teams understand how the interfaces with those managed services are. And lastly, is rethink your architecture. I think that's one of the most important things for me. It's not just grab your things and throw them in API gateways and lambdas, because that won't solve your problem. That will make more chaos. So yeah, don't forget that. Rethink your architecture. And yeah, that's all. If you have any questions, just tweet me or find me around. I will be hanging out until the end of the conference. So just ask on Twitter, because I need to go. Thank you.